slap, pow. These are all sounds that you're going to be hearing in the photoacoustic effect example of thunder and lightning. My name is David Ide, and I work with the chemistry department and Dr. Han Park in the study of the photoacoustic effect of ethylene gas. Where does ethylene gas come from? Alexander Graham Bell in 1880 discovered this effect using his photophone, putting a sunlight source through and getting a sound wave out. So all it really is the generation of acoustic waves through modulated optical radiation. So what is ethylene? Ethylene, it comes from ripening fruit in its plant aging cycle. So and it also has anesthetic properties, so it can be used in surgeries of that nature and anything else. But what is ethylene? It comes from the methionine cycle, and it's its byproduct from the cycle. As you see in this picture, it's on the back end over here at the very bottom, with the arrow where it's coming out at. Now, the point of this is that ethylene is combustible at 2.7%, and that's by the volume of the air, of course. But anyway, you can see in this picture of the Chiquita factory, you can see that the whole thing went up in flames because someone decided to spark a flame, or electricity just happened, I guess. But what we did in our experiment is you can actually see that we put ethylene in a tube, shot a laser at it, and then chopped the laser light with the chopper. And then the microphone picks up that sound, and then that sound went there to an oscilloscope where we can make our reading. And what we actually got to determine is that bananas produce 13% by volume, and avocados produce a 5% by volume. So it's actually a very, very flammable substance, and now you know what your food is producing. And this actually shows you that, you ever heard the plant in the bag to the apple and the banana? Well, they're actually going to be, this is why, because ethylene produces that.